Okay. Hello, yet again. So for those of you who don't know about Jun, it's actually quite amazing that he's standing here in front of you. So he got a bachelor's degree of biology, well, actually it's fisheries.
Yes.
So Tokyo University of Fisheries. And then he joined the Japan Coast Guard, where he was involved with a lot of sort of outreach and community conversations about environmental awareness, and helped sort of investigate the early sort of Fukushima damage back when that happened. He found out about our program and decided that he wanted to do a bit more with a degree. And when he originally came, he wanted to do a thesis in our program, but his boss would only give him 2 years and it was just impossible. So then he went over to EV where he had the option of doing an internship. We had all these lovely internships arranged and everything was perfect. He was going to do this and this and this and this and this, and COVID happened. So then he had to go home as everything was shutting down and went back to work. And we decided after some just prolonged sort of, okay, this is a long-term thing, decided that the only option was really to do the coursework option in EV. So he was one of the first that anybody's had any experience with guiding through this process, because it's an option that hasn't been utilized by very many people. But in this case, it worked. It was about the only way that it could work. So he took a couple of more classes online, you know, as that was happening. And so this is his final capstone paper. He's been through quite a few family issues, working full-time during COVID, and he has finally come to this point where this is his culminating project, which he has actually managed to finish under a lot of adversity. So I am very happy that he's here, and he's here in person. So this is not even an online thing. So we're very happy to have him here. Over to you, Jun.
Yeah, it takes a long time to come here. And I'm Jun Saegusa. Thanks for joining today. So, oh, hold on a sec. Who's that one?
Oh, somebody else?
Yeah, no,
Yeah, just admit.
it's lost.
Oh, meeting being recorded. Yeah, so just say, go ahead.
Got it. Oh.
Yep. Yeah.
Okay, so my project is about the name of the project is a literature review on the problem of the marine debris with a focus on plastics. So thank you for Marine Laboratory guys and the University of Guam. And my study is funded by the National Personnel Authority and the Ministry of the Land, Infrastructure, Transportation and Tourism. So long name.
So I want you to focus the camera on you.
Okay.
Yeah.
Oh,
Just turn.
Just, yeah, turn it to say.
oh yeah, one.
There you
Okay.
go.
Yeah.
Okay, there.
And Japan Costa, thank you very much for everything. And let's get started. Oh, yeah. What? What is? Oh, yeah. Okay, so these are the contents today. Introduction, objectives and search methodologies. What is marine debris? Where are they? What are sources? Environmental and health programs associated with plastics, international trends, solutions, and problems in Japan, and suggested studies. Thank you very much. So let's start from introduction. So since the first plastics was synthesized in 1907, the plastics are very useful items for us, and now that's why the plastic production has been increasing, right? Has been increasing exponentially, but along with the growth, the plastic waste also, has been increased. So, and unfortunately, some of them are leaked into the environment. Now there are so many, beach is like this, full of debris. And there's an estimation that by 2050, the oceans are expected to contain more plastics than fish. So, yeah. And then objectives of this study. So I did the literature review to understand what is going on about the marine debris. and find out some knowledge gaps from them. And then, and these through the literature review, I found out these items and then suggest the possible approaches. These are the framework of my thesis, report. So search methodologies. So literature review done by through the internet. And the example of the search keywords are such as plastics, marine debris, microplastics, toxicity, marine lives, and solution, etc. And these words are combined each other to narrow down the search result. And of course, I tried different combinations. So let's start from this literature review part first. So what is marine debris? So United Nations Environmental Program, we call it UNEP, define the marine debris as any persistent, manufactured, or processed solid material discarded, disposed of, or abandoned in the marine and coastal environment. So this, in other words, all artificial objects discarded in the marine environment. So what is plastics? So GESAMP, the scientific board of the United Nations, defined the plastics as synthetic polymers that's soft on heating and can be molded. So because the plastics have ideal properties such as low cost, low density, durability, and barrier, it's very good for industry. So that's why the plastics production has been increasing here. But that ideal properties can be turned to be environmental threat. Like, the light means it's easy to spread everywhere, and durability means it lasts for a long time in the environment. And barrier, hydrophobicity, means the plastics can accumulate chemicals in the environment. This is very big environmental threat. So, and what is microplastics? I think some of you guys have already heard about this term. And microplastics means plastic particles less than 5 millimeters in the marine environment. And this is samples of the styrofoam particles collected in Japan Sea. The white ones are styrofoam particles, and this is collected with the sampling, the plankton sampling. So there are some planktons also get in together there. So microplastics can be divided into two types. One is the primary microplastics, which is small when it's generated. For example, the plastic resin pellets, the raw materials of the plastic items, or the effluent from washing machine and tire wears are also the source of primary microplastics. And the second microplastics are generated from the big items, breaking down into the small pieces through the micro-based activities and sunlight and UV and heat and hydrolysis, etc. So where are they? So we can say that they are everywhere in the world, including sea surface, beach, seafloor. You can see floating debris like styrofoam or fishing gear, and so many pet bottles at the beach and tires on the seafloor. So, and studies demonstrated that they even existed in remote areas such as Antarctic Ocean. So we can say they are everywhere in the world. And although I told you they are everywhere in the world, there are distribution. So this figure shows the global distribution of the plastic particles, and the gray parts are the accumulation zone, which is made by the global wind pattern, and the Ekman transport made by the wind. And some studies have demonstrated that the plastic debris are debris have been found in the more plastic debris are found in the accumulation zones like this, and they also suggested that the accumulation zones are located in the on the 30 degrees on both north and south. And beach debris has also spatial variation. This is a result of the International Coastal Cleanup, which is a volunteer event, cleanup event. And you can see that so many, waste from our daily life, such as food wrappers, cigarette butts, beverage bottles, etc., etc. So this is because these results from the the beaches which is accessible to people. But accessible, yeah, accessible. So I think it's maybe near from town or it's easy to get in the car. So yeah, these are our daily life products are predominant here. But on the other hand, in the remote area, this table shows the top 10 items recorded at the remote beaches in Japan, and you can see some of the the items which is not related to our daily life, such as ropes, fishing gears, and packaging tape. And we also noticed that there's no cigarette butts here, so it's totally different between beaches. Yeah, and the spatial variation is also exists in the seafloor. It's related to the economic activities. So this figure shows the site of the seafloor monitoring at 3 places in Japan, and blue circle area. The blue circle area is the East China Sea. The many fishing activities are conducted there, and from this site, more fishing gears are collected from the seafloor than other 2 sites. And on the other hand, in Hokkaido area, which is very, big agriculture area. So they use green sheets for the plastic sheets for greenhouses. And they also found that there are more plastic sheets on the seafloor from this area than other 2 areas. So this seafloor debris are related to the economic activities. And it's also related to the topography. This figure shows the distribution of the seafloor debris in the Monterey Canyon. And the blue one shows the big blue circle shows more debris there. And you can see that most of the debris are in canyon, right? Not so many in the flat area. So they also suggested that the canyons have a function to collect marine debris. And so the input from the coast like this, and then the local current transport those marine debris input from the coastal area to the canyons. So yeah, it's related to the topography. And there's one big problem about the plastics. So missing plastic problem. So this is that some studies showed that have been shown that the lower number of plastics observed than what would be expected. So considering that there are so many plastic wastes already exist in the environment, but less marine debris are observed so far. And this is an example of the missing plastics. And this figure shows the result of the marine debris sampling from the sea surface. And x-axis shows the size range of the plastic particles, and the y-axis shows the amount of them. And when you think about the microplastics, when the microplastics can be given by the bigger plastics break into 2, right? Or a quarter. So that means smaller ones more and big ones less, right? So from 5 millimeter to 1 millimeter, it goes well, right? Like exponentially, but from 1 millimeter suddenly drop. So this is an example of the missing plastics. So sources. So where marine debris came from? So not only sea-based, but also from land. So when you hear about the term marine debris, it's a problem of, it seems like a problem of the sea area, but they are from the land area. It's related to our daily life. And of course, from the sea area, from fishery, shipping industry, or agriculture. So let's look at the land-based sources. This figure shows the global map of the land-based sources, and the brown part has more plastic waste leaking into the ocean from the land. So the author of this study suggested that there are 8 million tons of plastic waste annually were flown to the ocean from land, and most of them are flown to the east and southeast area along this area. And another study suggested that the origin of the 70% of the marine debris was land. So most of the marine debris comes from land. So what about the sea-based sources? So there are still so many, fishing buoys here, styrofoam buoys, and fishing gears. I think these are the eel traps, which is popular in the East China Sea, and ropes. This is used for both fishery and shipping industry. So what is the source of microplastics? As I told you, there are primary microplastics and secondary microplastics. And look at this figure. This is a share of the source of primary microplastics. This one's the effluent of the laundry accounts for 35% and 28% for tire wear and 24% for the town dust and 7% for the the infrastructures maintenance. So you can see almost all of these sources are from 99% of the primary microplastics are generated during the product's use or maintenance, and only resin plates here, the production step accounts for only 0.3% of this. So when you focus on the primary microplastics, you need to focus on the product's use or maintenance stage. And in total, 151,000 tons annually inputs are, and the inputs exist for the primary microplastics. And about the secondary microplastics, it's very little is known about the generation of the secondary microplastics. But considering that it's already, there are so many considerable amount of marine debris already exists in the ocean. So maybe a certain amount of secondary microplastics is generating now. Next, environmental and health problems and impacts associated with plastics. So how marine debris affect the environment? So physical impact like entanglement, ingestion, and effects of pollutants in marine plastic debris. So entanglement. So the number of the species group reported to be entanglement was 344 species at the time in 2015. And that includes seabirds, fish, invertebrates, marine mammals, sea-turtles, and sea snakes. And entanglement makes creatures can become immobile and starvation or suffer wounds and infections. And ghost fishing is one of the big problems of the entanglement. So I need to explain about the ghost fishing now. So the ghost, when the fishing gear is abandoned, then nobody's touch it, but the fishing gear still keep catching the fish. You know, for example, the crab pot abandoned on the seafloor, and maybe the crab is coming in, but no way to get out because it's a trap. So but nobody takes it, right? So it will die there, and the rotten meat of the crabs can attract another crab, right? So the abandoned fishing gear was, fishing gear keeps attracting the other crabs and other sea animals. So that is a ghost fishing. So that's a waste of the resources, right? This is not good. And ingestion. So 331 species was reported so far at the time in 2015. And that includes zooplankton, corals, oysters, fish, birds, station species, seals, etc., etc. And the fish, the ingestion of the fish is reported in the, there are most number of the reports as issued already. So let's focus on the fish today. So what happened when plastics are ingested by fish? So most of the plastics are retained in the digestive tract, but fine plastics can translocate to the other tissues, such as skin, gill, or muscle, edible part. And also there's a physical damage. It's a bit difficult to show in this figure, but this cod ingested the rubber strap longer than him, and it was found that the weight of the cod is a bit lighter than the average one. So they also suggested that the growth of the cod is blocked by the this rubber trap. So yeah, physical damage. And hazardous chemicals. There are two kinds of chemicals in plastics. The one is a part of the plastics when it is produced for, such as cartridge or flame retardant. And another one is that the plastics can accumulate hazardous substances from the environment because it's hydrophobic characteristics. That's why the plastic can vector hazardous chemicals in wildlife. Well, I have a question about that. Did the pollution in plastics have adverse effect on the environment? Is it serious? Well, actually, it is still a controversial matter. Scientists said that the transportation of the hydrophobic organic chemicals can be negligible because water accounts for 98% of such chemicals transport, but while plastics accounts for only 0.0002% of it. Another one said that it can be negligible because when plastics are polluted due to the ambient environment, the fish is also polluted, right? So when the polluted fish is the polluted one, nothing happens, she said. So I have one more question. Are we eating plastics through the consumption of seafood? I can say yes, because plastics are included in edible parts of the seafood, such as fish and mussel. And one study told us that mole dishes are common in Europe, and it's estimated that some group of the Europe guys eat 11,000 microplastics per year through oyster and other shellfish. Ooh, some of you already have it. And I have more questions. Are they transported outside the gastrointestinal tract to other tissues? Like I say, it's possible, but size dependent. So microplastics of 150 micrometer or less are present in the edible part of fish and shellfish, sorry. And plastic with a size of 150 micrometer or less can be absorbed into the body. So it's possible. Wow. And the final part, are these plastic particles in the body through the seafood consumption harmful to us? And I can say it's not sure yet, because there are various routes of intake of microplastics. So with the breathing or drinking water, so many routes to intake microplastics in your body. And that's why there's no clear conclusions or standards regarding toxicity to humans. But we can say there are possible ways of adverse effects to the human body, such as caused by pollutants via plastics, and physical adverse effects such as inflammation. Okay, let's go to the international trends. So, in conclusion, the marine debris includes plastics is recognized as a worldwide problem. So starting from the G7 summit in Germany in 2015, leaders of the G7 countries, including United States and Japan, recognized that the marine debris as an international problem. And this is for the first time in the G7 meeting. So after this event, activities to approach marine debris problem have been promoted. So look at the recent activities. So the G7, recognize the marine debris problem is a worldwide ones. And G20, it's expanding to more countries. Recognize that the Osaka Blue Ocean Vision as a common goal of the reducing the additional marine plastic pollution to zero by 2050. And they also agreed to share strategies with countries beyond the G20 states. So it is expanding more. And also the business entity is interested in this problem. The World Economic Forum summarized the problem and reported that the plastic waste is projected to outnumber fish by 2050. And they also discussed what they can do for this problem. And final one is the United Nations. Now they just started their negotiations to create an international legally binding instrument between member states by end of 2024. So this is a recent movement of the international trends, and it's going up, right? So solutions. Monitoring. Monitoring is very important because the results of the monitoring can answer your question, what we should do for the problem. So these are the monitoring activities, collect the collective debris at the beach, or how to say, tow the plankton net on the surface. And for example, this is this figure again this is the result of the beach debris. And you can, when you focus on the food wrappers and cigarette butts, they are top two here. And if you want to approach these items, for example, you can talk to the industries of the food wrappers, candy company, or chips, etc., or cigarette companies. So the result of the monitoring can answer your question, what we're gonna do, what we should do. So it's very important start for the solution. And waste management is also important, very important. The most important measures to prevent the generation of the marine debris. So considering the 8 million tons mismanaged plastics were flowing into the ocean annually, right? It's very important, right? We can understand it's very important. Waste management is very important. So, and it's very important to extend the lifespans of final disposal site by reducing the amount of waste by, for example, incineration or recycling. And this is very important for the country which has very small land, such as Guam or Japan. So it's very important. So behavior change. It is very necessary for truly clean marine environment. The Williams and Trago said strongly that. And yeah, and there is a, for example, financial approaches. One is taxation on unsustainable products, which is recommended by UNEP, and buyback system for fishing gear. It worked. Yeah, it is demonstrated to be worked. And posters with marine life suffered from marine debris. It seems to be simple, but it works. Yeah, it demonstrated to be worked. So let's try this one later. And regulation or elimination of the single-use plastics are very important because they are wasted soon. So it can be a target for the regulation. So the single-use plastics, including the plastic bags, food packaging, bottles, straws, containers, cups, cutlery, etc. And that's why the national plastic bags ban or styrofoam regulations are now expanding nationwide, worldwide, and South and Central America and Africa, Europe and Asia. And recycling. Well, recycling should be a part of the solution. It's not working now. Because now for example, in the US, the recycling rate has remained less than 10% from 2005 to 2018. And also there's a very shocking event related to the export. So developed countries so far relied too much on exporting plastic waste for recycling. So these figures again. So why this China is turned brown here? Because the China had imported so many plastics for recycling. So before the report, the JAMPEX report, this report was issued, China imported so many plastics that more than 8 million tons of plastic waste they imported. Oh, sorry, this figure shows the plastic waste imported by China and its top 10 countries which exports marine debris, exports plastic waste to China. And yeah, once they have the more than 8 million tons, and Hong Kong, Japan, United States, Thailand, Germany, so many countries here. But at the end of the 2017, China started the regulation not to import the plastics. Then now in 2020, the amount of the imported plastic waste are now 300 tons. So much difference. So so many countries need to consider about the recycling or to find another way of the export, another country to export or recycling in their own country. So yeah, now this is a very shocking event for recycling. And how about biodegradable plastics? Well, it's possible to reduce plastic waste. But each biodegradable plastic product has its own appropriate final disposal environment. What does this mean? So I can say that almost all 99% of the biodegradable products need to degrade it in the compost, right? Compost, artificial environment. Yeah. But only 1.2% of the products can be degraded in the environment. Yeah. No products can be degraded in the marine environment. So I can say biodegradable plastics sounds alright, but it's not a good solution for littering. Be careful. So the problems in Japan. So this is the location of Japan. Sorry, again, this figure again. So here, it's Japan here. And you can see the Kuroshio current here. So I think you remember that there's so many plastic waste are flowing into the ocean from these countries turned brown. And there are so many marine debris exist on here, and Kuroshio currents brings all to Japan. So this is a precise image of the current ocean currents in Japan, around Japan, and this is a Kuroshio, and it's split in two for the on the Pacific side and the Japan Sea side, and then this one's still Kuroshio, but this one is named Tsushima Warm Current. And yeah, this beach is located here. So this is the entrance for the Tsushima Warm Current to Japan Sea. So the island blocked so many marine debris here. So that's why it's always full of the debris here. And that's why the Japan is called as a hotspot of marine plastics, microplastics. So Isabeto 2015 find out that the East Asian seas, in this study, East Asian seas means the sea area around Japan, have more plastics than other areas such as North Pacific, World Oceans average, or inland sea. So the location and the ocean current, wind, and and such kind of correlation makes this result. So that's why Japan has been suffered from marine debris, especially for beach debris. So that's why the Marine Litter Act was established. It was enacted in 1929, and it established who is responsible for cleaning up marine debris. So before this Marine Litter Act was established, there's a common rule that law that the generation of the waste, how to say that it is responsible for whom generate the plastic waste to be cleaned up them, right? So, but in most cases in marine debris, the generator of the waste are unknown, right? So that's why the local governments or volunteer groups clean up them as requested by citizens. So they are very burden for them. So that's why the Marine Litter Act defined who has the responsibility. So the manager of the cost, usually local governments have a responsibility to clean up the beach, but this is not enough because it needs budget for cleanup activities, right? So the Marine Litter Act also defined that the national government shall take financial measures required for actions against marine debris problems. So that means national governments needs to provide budget for cleanup activities. So these ways helps the marine debris cleanup nationwide now. So because of the Marine Litter Act, Japan is taking these actions, such as conduct annual research for marine debris, and leads harmonization for monitoring worldwide to compare the results of the monitoring activity worldwide. And governments are doing well about the waste management. Theoretically, 100% of waste has been collected. And also the government provides assistance for establishing waste management facilities in East Asia. And this is very important because when this kind of facilities can prevent plastic waste flowing into the ocean, right? So that means that if we can prevent the marine debris in the East Asia, that means it can reduce the marine debris comes to Japan via Kuroshio. So it is very important for us. And Yeah, the government also created the portal site for sharing marine debris information based on the G20 agreement. So yeah, Japan's doing well, I think. So let's go to the suggestion part. What is the possible approaches on this program? So the first one is investigate the problem of missing plastics. So it's necessary to obtain field data to present a realistic scenario for laboratory experiments. So in some cases, in some studies, to get the good result, some scientists put so many microplastics in a fish tank, and that's the unrealistic concentrations. That happened already. So it needs to present a realistic scenario by the field activities. So I suggest to increase surveys at less monitored sites such as seafloor or water column. And also, yeah, evaluate the current monitoring methods, and if necessary, it needs to be improved. So this is an example of the missing plastic, and some studies suggested that this is given by the collected. These samples are collected by the plankton net, and the smaller particles can go through the net, right? So it can be improved. And another one is that examine environmental risks of biodegradable plastic debris. So it sounds very eco-friendly, right? So the production capacity of biodegradable plastics expected to be increasing. So around 2 million tons in 2020, but it's increased to 7.6 million tons in 2026. So good, big jump up. But the biodegradable plastics can continue to remain in the marine environment, as I told you, and they are already found in marine environments. So I think it's urgent to make assessment due to the expected increase in production volumes of the biodegradable plastics. Assessment of the risk is very urgently needed. So this is a final suggestion that I think it needs to evaluate the existing approaches. So I have a question that management activities seriously effective in achieving the objectives? So objective, in other words, the ultimate goal, right? Ultimate goal of the approaches is that to reduce the number of plastics in the marine environment, right? So I think everyone can agree with this one. And for example, I wonder, is plastic ban policy appropriately working? So I found a negative result of this. Sales of other plastic trash bags increased after plastic bags were banned. So I think the total amount of plastic bags are not changed, I think. So I suggest that to check whether the policy really helps our society to approach the goal. And I also suggest that to compare the fieldwork results before and after the introduction of the regulation. If it's changed, we can see the effect of the policy, but I haven't found this one. Yeah. So yeah, that's all. Thank you very much for today. And thank you for, I want to say thank you for all of you guys here in this room and on video, and thank you for committee members and especially for Lori. You gave me tons of advices, and maybe you have so much patience. Thank you very much, and thank you all on this list. Thank you very much. Yes, that's all. Thank you.
Yeah, so anybody have any questions for Jun?
Was there any indication of harm, health harm from microplastics transferring between a mother and a prenatal infant of any species, human or animal?
Oh, okay, so that is, I know one, one hypothesis related to that one that I know. It is, I say, the plastics can be transferred to the, I say, predator and prey. Yeah, it can be transferred, but I found that the biomagnification is not happened. Yeah, many studies said so, but I'm not sure about the mother from son, right? Or kid, I mean kid. So I'm not sure about that. Sorry.
Vertical transmission.
Vertical transmission. That's very interesting.
That it can be transferred from a mother's milk to its infant. I think whales maybe have that observed, but I don't know about prenatal in that.
Well, that's
Through the blood, yeah.
yeah, that happens because the tiny ones are already in our body, so and tissue, right? So it happens, but yeah, thank you very much. I need to search for this later. That's later. Thank you. Okay, yes.
Totally different thing. Has Japan's legislative policies of promoting waste management in neighboring countries in East Asia, has that had any net result on the waste showing up in Japan?
So you're asking that, is it decreasing, right? Oh, well,
Anyway, yeah.
well, for example, beach litter has many sources, right? Some from maybe China or Korea or many countries, right? So even though we built one facility, for example, in Indonesia, I think it's very difficult to evaluate the effect to Japan beach, right? But I think we can do it, for example, in the Indonesian beach after the facility built, then maybe it declined, then we can see the effect. So, well, yeah, from one beach, yeah, it's a bit difficult. Yeah. Okay. Oh, so which Ash? So yeah, Ash, yeah.
So you had a statistic about how in the United States, less than 10% of plastics get recycled. Does Japan have numbers for that? Because they do a much better job recycling, it seems like.
I heard that the PET bottles, we have high percentages, like I'm not sure about around 70 or 80. Yeah, it's so high because Japan is a very small country, right? So we always think about, oh, we need to separate our trash from plastics and the garbage one or hard one and so on. So we always think about that. So that's why the recycling rates are high. But sorry, I have no exact figure now. Sorry.
Thanks.
Oh,
On that map that you showed with the darker and lighter countries,
oh yes.
was that overall plastic?
Oh yes. What? This one. Yep. Those. Yep.
Is it per country or is it per person? I was just wondering.
So
Available to enter the ocean.
Right.
That was in 2010.
But it's also, it's irrespective of population size.
no, they also calculated the number of the people on the coastal area from within 50 kilometers from the beach and the waste management system and
That's
So
not
it
on the
doesn't
map.
sound like it's.
economic activities.
But that's not on the map. The map is just total plastic production.
Oh, right. So this is just showing just a result of the calculation number. Yeah.
So yes.
Well, yeah. So there are so many people living here, so that's why. Yeah, right.
So what are the whites again? Just.
Oh, so
area?
yeah, I figured out so that no, these are not the coastal area, right? Not the
Right.
coastal country. So they're also exclude
There's also anything that doesn't have coastal.
Right,
Is-
but I'm not sure about this one.
That's.
Still, the here is a, oh, sorry.
Oh, probably, you know why? Because Greenland is
Only, it's only populated around the coast, right?
Oh,
So maybe there just aren't any people in the middle that would be contributing.
yeah, maybe, yeah. I've read through the paper because you told me about you asked me that question yesterday. But yeah, so that makes sense around here, right? There's no coast area, right? But I'm
Coastal.
not sure about here.
So those are geographic boundaries, which means even if the country, yeah, like that one, yeah, so China, even though China doesn't have that, a very large coast, and there's a lot of boundaries around China that aren't in contact with the marine environment, it's still geopolitically that belongs to China.
Mhm.
So all of China's rivers would end up going toward the coast or something. Okay, that makes more sense.
And it's plastic waste available
Yes,
to enter the ocean.
right. So in other words, this means the amount of the waste plastics inappropriately deal with, so dumping or, yeah,
Okay,
not on the route of the, facility and not going to the final landfill. Yeah. Yeah.
Phil, I had a question. You didn't mention the great garbage patch too much or?
Oh,
very
yeah.
little?
Yeah, because
And I was wondering because there's been a lot of people talking about it lately. And
Yes.
some people are saying there's so many organisms growing. Everyone agrees, stop the plastic from going to the ocean. That's smart. But there's been debate on whether to take out the plastic from the great garbage patch because there's so many species living on it.
Yeah.
It's like a new ecosystem. What do you think?
so. Yeah, the ecosystem, right? So it's a work as a habitat, right?
That's what they're saying.
Mm.
I'm curious your opinion. You did a lot of research now and
Oh, well, I don't think about that. Well, yeah, for example, not only the plastic waste on the sea surface, but the seaweed have been a role of their, function of a role of the, the houses or for the small tiny fishes, right? So, well, for the tiny fish, it's beneficial for them. But when it's bigger and once you touch it and finally, it's caught by the, for example, fishing net or floating, right? So it's not working good as the floating weed does, I think. So, but there is a possibility to such species can have a benefit, but at the same time, they have the negative effect. So it need to be, tested. That's a very good point. I want to dig into that. Wow, thank you. Did I answer your question?
no, I just read an article like maybe 3 weeks ago or something.
Oh,
They discussed the argument. And then I said, I'm gonna ask you.
thank you. Oh, yeah, the farm.
Have you looked at how the different densities of plastics spread, like the floating plastics, how they spread versus negatively buoyant plastics, how they spread?
Yeah, sorry.
So we have like low density plastics that float
Oh, yes.
and higher density plastics that will sink.
Yes, thank you.
Have you looked at the differences in how they spread around the world?
Oh, so the floating plastic can go everywhere, right? Very simply, I saw the result of the simulation that they're starting from China with the north wind, the styrofoam buoy can go instantly to the south area. Yeah, but there's a relatively, I say heavy one on, but still on the safer surface. This only affects from the ocean current, right? So they differently moves each other. And about the debris on the seafloor, it's slightly, slowly moves to the, deep area or along the sea current, sea bottom current. So it's totally different. Yeah.
And just a selfish follow-up, how do you think the Marianas Trench is doing right now?
Yeah, I found that there is one plastics has been founded in around 10,000 meter in Mariana Trench.
10 kilometers.
Yeah, 10 kilometers. So I think there are more or they increase in the Mariana Trench. But I think is it going down?
Yeah.
Sure.
It's a subsidence.
Yeah, but it's very interesting. Yeah, I won't see that.
Gonna go down there someday.
I'm sure I will.
Just had a quick question about your methods for your literature review. What database platforms did you? use?
Platforms.
Scholar,
So
Scopus.
Google Scholar and
Web of Science?
yeah, it's a ResearchGate, and it's okay to say Science Hub. Well, something like that. Thank you. Okay.
I thought of this after David's question. So could you go to the heat map on the other slide really quick, that different brown color map, right?
Oh, yeah. Like, this one is very popular, yeah. I was shocked when it was issued. Oh, yeah. Go ahead.
So you highlighted that China imported a lot of plastics around 2016.
Right.
And I'm guessing that this might be related to them still having been importing at the time.
Right.
How do you think this map would differ based on who is likely to have started importing more plastics and or people being less able to export plastics? Where do you think a redistribution might be of this color intensity? Where would be more brown, where it might be less brown than it is in this?
Okay.
Oh, like
That's
right
a
now.
Very good question. So I think that after this study is issued, the China moved to ban exporting, right? So that makes China maybe more, I say, light color, but at the same time, that means they lost the source of the raw material of the plastic items, right? So that leads China to import, raw materials, the new one, right? So I'm not sure about how that affect to the result. So this is a result of 2010. So now, it's kind of a bit different from this one now, right? So it's very important. I want to ask her, about that. Thank you.
You think that Southeast Asia would be darker brown than it is in
Well-
this map, or would it stay the same now?
Stay same or a little bit getting better, I think.
Okay.
Because many now the international trends are now going up, right? So everyone thinks this problem as a bit serious ones. So I hope these colors turn a bit lighter.
Lighter.
Yeah,
Well, that would be good.
thank you.
Yeah, she should redo her study.
This is kind of a random, I don't know if you looked this up, but now that China's stopped importing other countries' recycling, has any other country taken up that?
Right. So that happens to the recycling. So other countries started to import that one. So that means the developed countries find another way to export the recycling waste. But after that, I didn't tell you that there's a Basel Convention which restrict regulate the very dirty plastic waste to be exported. So before that, convention regulated that such kind of plastics, hey, just throw it to the developing country, right? That happened. So after China did that, also the Basel Convention was renewed, then, hey, stop it, just stop it. Yeah, so don't do that because, the developing countries cannot, handle the, dirty plastic waste, just they gonna throw away and then they will make the more marine debris plastics, right? So that happened, yeah.
Any more questions? Okay, so, you have many congratulations messages in the chat.
Oh, really?
The last one being from our grad program vice provost. Congratulations, June. Thank you for sharing your research. Huge shout out to your thesis advisor committee members and program chair for their support and mentorship. And that is from Dr. Santos Bamba. So, and you've got a whole bunch of other ones up here. Everybody's just like, congratulations, Joe. Okay, so thank you all. There is food there, and now we must convene with his